So I was asked to talk a little bit about what happens in industry, how do we benefit from the research, the excellent research that is taking place in Sweden. And just to give you a bit of background here, this is where I come from, Ericsson Research Security. I head up the security department then within the research organization, which is a global organization, so Ericsson worldwide. What we do is to define, prototype, and standardize security solutions for future mobile networks, which place us in the time span of 3 to 5, sometimes 10 years ahead in time from now. And we engage in academic collaborations. We also have a very close interaction with the business areas at Ericsson. So this places us somewhere in between product development and academic research. And we also engage in external projects to a fairly large extent. And we also communicate a lot about what we do. So we have academic publications, blogs, white papers, and so on. So a lot of these things are actually available. And a few examples of collaborations that we have ongoing now is Concordia University in Montreal in Canada. We had a collaboration for quite some time there. It's focusing right now on security audit compliance and also new challenges for 5G and beyond. We have RISE in Sweden. We're here today. And this is also a long-standing collaboration. One of the things we're doing is lightweight security. I'm going to come back to that. We have EU Concordia, which is a cybersecurity competence network within the EU, where we also participate. And we have HexaX, which is the EU flagship project for 6G, where we contribute to security aspects. And then in the US, we have the NFS Rings, so the NSF-sponsored program for resilient and intelligent next-G systems. So these are a few examples. So we participate in many more, we contribute. But today, I was asked to focus on Sweden, and a little bit more about what we do in Sweden and also what's happening in Sweden and how we can make use of this. And I thought one way of doing this is to share a few examples. So the first example is SNOW. And SNOW is an encryption algorithm. It's a stream cipher that was developed by Lund University. And the outcome of this research project was so good that Ericsson took an interest. Ericsson Research engaged in bringing SNOW to standardization. So first it became an ISO standard, and then it was taken to 3GPP, which is the standardization body then for mobile networks. And as part of that process, it also went through the crypto experts of ETSI. So there were some testing done and some modifications made, some slight adjustments, and in the end it came out as something that is called SNOW 3G. And SNOW 3G is the stream cipher used for air interface protection in 3G, 4G, and 5G. So it's used for confidentiality and also part of the solution for integrity protection of the air interface, which means from the device to the base station and vice versa. And SNOW 3G is a mandatory part of the 3GPP standard, which means that it's used in all base stations and all devices worldwide for 3G, 4G, and 5G. And this means in the order of 7 billion subscribers worldwide, including us here. So I'd say, if you ever ask yourself about the benefits of cybersecurity research in Sweden, the answer, or one answer, is in your pocket. And because this was a very good work, and because it's also fun to do this, we have continued to work. So we have continued collaboration between Ericsson Research and Lund University. Many exciting topics, but one of them is also a version of SNOW for virtualized environments, which is in progress, and it's currently called SNOW 5G. So that was one example of academic research coming into use. The next one I wanted to talk about is the lightweight security suite. And these are lightweight security protocols for low power and sustainable operations and the Internet of Things. So when you have very small things like sensors or very tiny devices, and you don't have a lot of computing power, and you don't have a lot of battery, so you need to really keep things low power, both for communication, also for security. And this is a joint research work. It started out from a collaboration between Ericsson Research and RISE in Sweden. It now includes a number of research institutes and a number of companies, so also outside of Sweden. This collaboration includes standardization in the IETF, so the Internet Engineering Task Force. And only last year we had a number of RFCs coming out, so a number of finalized standards for these lightweight security solutions. And what we see now is that it's being implemented by industry. So a few examples. We have health and fitness monitoring. You have a small device somewhere on your body helping you for monitoring. And then we see the use of the privacy solutions from this lightweight security suite. We have agriculture, where you have a number of sensors and you want to communicate to them all at once, and there is a solution optimized then for group communication, which makes it more efficient than to just communicate with each one. Hydropower plant and communication with sensors in there. And there we see the use of the access control solutions from the lightweight security, and also locks, remotely locking or unlocking doors, for example. There we also see the use of lightweight security. So these are things being implemented by the industry, and I'm not talking Ericsson only, I'm talking about the ecosystem at large here. The snow that I talked about earlier, that work was initiated around the turn of the millennium, so 20-something years ago. The lightweight security was started, I'd say, roughly a decade later. So I think we still haven't seen the full impact of the lightweight security suite. I think this is something that will come in the coming years, but we see the beginning. And then if we move another 10 years ahead, so 2020 roughly, give or take, we are currently working on cyber threat modeling. And cyber threat modeling describes the chain of techniques that an attacker can use then to target something. And this gives a very structured way of describing how that attack was performed, which is really useful to learn about the attacks, but also to do, for example, threat analysis and decide what kind of security measures you want to take to protect what you have. And there is something called the MITRE ATT&CK, which is a state-of-the-art cyber threat modeling framework, so mainly for attacks in enterprise networks. And because we are very interested in mobile networks are different, a bit different from enterprise networks. The threat landscape is a bit different. So it's difficult to use the MITRE ATT&CK framework as it is on mobile networks, which is why in this EU Concordia initiative that I mentioned earlier, Ericsson Research from Sweden and Telenor together worked on a cyber threat modeling framework for telecommunication networks. So there was a proposal and an implementation of that. And what we do now is, from Ericsson point of view, to leverage these results to actually contribute to industry initiatives. So we have, for example, the GSM Association working on a threat modeling framework for mobile networks. And then we also have the MITRE FIGHT, which is the 5G hierarchy of threats. And this is quite new, so we haven't seen the full results coming out of this yet, but it's quite exciting work, I think. So if we look a little bit then at technical, this is a very high-level picture, I should say that. But technical aspects then of the mobile networks, so for 5G and beyond, we see that there's still a need for technical research work. I think this need will never go away. So we have, for example, identity management, secure protocols, and underlying that is, of course, crypto in various forms. We also have solutions built on confidential computing, which links very much to the concept of zero trust. And we also start to look at hardware security more, in addition to software security. Security assurance is a highly relevant topic, has come up during the last couple of years, and we also have a demo out here on security assurance. AI was mentioned by Andre earlier, still relevant, and the security of AI and how to make it reliable so that we can actually trust it the way we do. And then privacy, of course, always important. And these are a few. I mean, I'm not going into depth here, but there is a lot of technical research in the cybersecurity space to do, and a lot of it that can come into use in the industry and in the ecosystem. So some final thoughts on this. When I think about research, I think that research and cybersecurity research, it's really good, but research in isolation only takes us so far. And I think this is something that has been mentioned more or less by all the speakers so far. We need collaboration. So research and collaboration, that's what can take us all the way into the future, I think. And from an industry perspective, how do we get a successful research and collaboration activity? And there I think the key thing is to listen to each other. So as someone said, we meet here today, we can talk, we can discuss, and also listen. Listen, and then adapt slightly to all the things that are being said and all the insights that are out there. I think that's the way to make something really useful. But then I also think, I showed examples now of where we have technical results coming into use in the industrial ecosystem, so worldwide. But I think the main benefit from the research is actually the competence build-up. So we have the competence build-up, we build the know-how, we learn from each other, there are recruitments, these people go into industry, larger companies, smaller companies, public sector, academia, and they continue to use all this experience and continue to learn. And this is how we build cybersecurity know-how in the ecosystem at large. And then this will also lead to continued collaboration and shared insights and also international collaboration initiatives, so to even further get this going. So I think that's the real benefit coming out of all this, the competence that can be used to actually address new things, problems, challenges in there. And the final thing I wanted to say is, from my experience, it can take a long time. So when we start a research project, we cannot always expect the result to happen today or tomorrow. Sometimes it takes 2 years, sometimes 10 years, and sometimes almost 20 years before it materializes. So let us dare to think long term, and let us dare to let the cybersecurity research take the time that it needs, and then it will be beneficial for all. Thank you.
Thank you, Eva.